Hello everyone, welcome back to my channel. I'm Soumya here and today we will be starting with our next 30 days of our 60-day study with me challenge for placement and internship preparation. So I'll be solving a question today. Was very much near enough of the question that was asked in the Google's interview. The concept were same. So we'll be solving it today. I'll be giving you multiple ways through which you can solve that question and how your thought process should work. So let's get started. I know most of us have solved this question with brute force approach or anything. I'll still want you to just stay back, watch this video as we'll be solving these questions in the multiple ways. It's an easy question to understand. You are given an array of integers where you have to find all possible subarrays, right? And after finding that subarray, what you have to do is you have to do some implementation on it. What is the implementation here required? You have to sum all the numbers of that subarray, and if that summation is equals to the k, then we have to return the outputs. So then we have to increase our count, and you have to count all those subarrays whose summation is equals to k. That will be your final answer, right? So we understood what will be our final answer. Here we can see we have final answer 2. So what sum arrays they took these two, then they took these two. Is there any other possibility? I don't think so in the first case. So we already know the question. There is basically a nums, that is an array of integers, right? We can say 1 2 3 4 5, whatever is the case. Let's first take the one that was there in the lead code, 1 comma 1 comma k is equals to 2 and output is equals to 2. So what's the step 1 that we think of? Obviously finding all the subarrays. So step 1 to solve this question is finding all the subarrays. Finding all the subarray. Step 2 is doing some operation on doing operation on the subarrays. Doing operation on the same. The operation that we have to do here is finding summation of all the numbers that are present in the subarrays. Step 3, we have to check if that summation is equals to k, then we have to increase the count of our answer. If sum is equals to k, answer plus plus, right? So there are different approaches to solve this question, but we'll start with the brute force approach, the approach that comes to our mind, like the silliest of approach that you can think of. So we'll go with the brute force approach. Now, what is the first step? The first step is finding the subarray. So for the subarray, what we have to do, we have to run 2 loops and find all possible subarrays, and then find the sum of summation of all the elements there, and then check for a condition that if the sum is equals to k, then just answer plus plus. So let's do the code writing. I think we'll just go for 2 loops. Dial 0 sorry, for subarrays, what we do, we only go till I, because we have to take all the bits, right? It's like if there is 1 1 1, then we have to take 1, then 1 1, then 1 1 1. Now we can see for the two loops that is running. So using these two loops we can find the subarrays. What was the operation that we had to do? The operation that we had to do here was summation of all the integers present in the subarray. So let's find summation nums of j. Make sure it's j, not I. Now the final step is to check if the summation is equals to k. If it is, then we have to increase the count of our answer. If sum is equals to k, then answer plus plus, what do we have to do after returning from both the loops? We have to return the answer, right? And here you can declare outside the loop to start. So this is a brute force approach. The time complexity here, what is the time complexity, guys? I think it's very easy to answer. Two loops are running, one is going till the n and one is going till I, but I in the worst case can be n. So worst case time complexity will be big O of n square. At least it's not 2 to the power n, but we'll have to improve our approach. Space complexity. In space complexity we have done a lot better. Space complexity is big O of 1, yay, because we only have answer and sum that we have declared. Using answer and sum we solved the whole question. There is no array declaration, there is nothing, so I think it's big O of 1, right? Now we can solve this question with the brute force approach. Who knows? Okay, let's start coding. Again we are doing the same mistake. It will be I. It will be I. I do this mistake very often. Practice, practice, practice makes a person perfect. Here again it will be j not I if sum is equals to k. Then what we have to do? Increase the count of our answer. Now return answer. I think we are done with this. Accepted. Okay, it takes a lot of time, not very impressive. We'll find another way to solve this question that will have a better time complexity, and I think space complexity is good. We can also solve this question through calculating the prefix sums. So we'll see. So let's understand this approach. So we are provided with this nums, then we are provided with a k, that is 2. We are provided with this k. Now what we have to do is we'll be declaring a map Map stores int, comment, like mapping to what? Okay, so what we will be mapping here? We'll be mapping the sum to the number of times that sum has occurred. Right? Let's do it. Now, for 0th index, what we have? We have sum is equals to 0. How many times the sum is equals to 0 is coming? 0. So basically, 1. 1. So basically, it's like 0 to calculating the subarrays, because we have to store the summation of subarrays, right? First is of one element, then second, then again it will be second, because you can see like this one is the first one, this will be the second, and here will be this and the whole. So how many subarrays is being created? 1 2 3 4 5 6. So this is being repeated 3 times, this being repeated 2 times, and one more is there, right? So basically we can say for 1th element it will be 0 to 1, that is 1. So basically it will be like then updated to 2 and then 3, and then for summation 2 this is 1. Okay, sum here sum is equals to 2, and here sum is equals to 3. So basically for 2 it is coming 2 times, and for sum 3 it is coming 1 time. Basically your map will look something like this. Now let's do the pseudocode. We'll be declaring unordered map. Okay, after declaring unordered map, we can say the 0th element, that is which is only present 1 times, so it's like mp of 0 is equals to 1. Now we'll be declaring our answer, I can say. So answer is right now 0. And go for a loop where we will be calculating the sum, that is where we will be extracting the subarrays. We'll also have to declare sum. Now sum is plus is equals to nums I. Now at this point, instead of declaring 2 arrays like we did in brute force, what we'll do is we'll only be using 1 array, like do the summation, you can say the block wise, that is first of the 0th index and 0 and 1th index, then 0 1 and 3rd index, and the cases that we will be missing. So we'll go here, we'll say we have 1, go here, we'll say we have 1, then again when we go here we'll say we have sum 2, Then again, so what we'll do is, this sum is 1. What do we need? Like, we need k is equals to 2, right? Now we can say, if I have an element with sum minus k in the map, will it work? Yeah, it will, definitely. So we'll check if map dot find sum minus k is not equal to map dot nth. It means if sum minus k, that is the integer minus k, is present in the map, so there's a possibility that there is a subarray that we are missing, that whose summation is equals to the k. So what we'll do is, we'll just increase our count to MP sum minus k, right? So what we were storing in MP of sum minus k, it was the number of times, that number of subarrays that were present with the same summation. What we'll do is MP of, after that we'll also be storing that sum that we had here in the map for further reference. Count, right? Now we can do a dry run and see if the missing cases was actually covered or not. Let's pick a different case. 1 1 1 we have seen in the brute force approach. Now we'll go for 1 2 3, the nums, and k given is 3. Okay, so is an unordered map. Here's an unordered map that will get mapped. Basically, this is a map. Now I is equals to 0. I is equals to 0 right now, and sum is equals to nums of I, that is 1. Okay, first of all let me store this, because this case, right? So for sum 1, I'm so sorry. For sum 1, what is sum minus k? K that we need 3. So 1 minus 3 is 2. Is there any 2 present in our map? No. Right? No. So what we'll do is, we'll just go and store our sum, basically 1. Now we'll again move on to I is equals to 1. Now what is the sum? Sum is 3. So is there any sum minus 2 is equals to 1? Is there any 1 present in the loop? Yes. Sorry, in the map. Yes. How many times? There is only one subarray with sum 1. So count will get updated to 1, and our map will also get updated to 3. Now we'll move on to I is equals to 2. So basically, for I is equals to 2, our sum will be 6. 6 minus 3 is 3, right? 1, so sorry, it's 0, and yeah, it will be 1 only. Yes, it's present. I'm so sorry guys, it will be like 3 minus 3. I just got confused with the k in the previous one. So it's like 3 minus 3, so it's like 0. 0 was also present in the map, so count will get increased to 1, okay. So we moved on to I is equals to 2. Here we have got the sum 6. Now 6 minus 3 will be 3. Is there 3 in the map? Yes. In the previous iteration we saved it. So our count will again get increased. So plus 1, that is 2. Now again we'll store this 6 in the map. Now we'll go I is equals to 3. Wait, our condition for the loop doesn't satisfy because 3 is not less than 3. Because 3 not less than 3, it's wrong. So we'll move out of the loop and now we'll return count. So output will be So output will be 2. Is our answer 2? Yes. We finally did it. So now you know that these sum minus k actually includes these cases. 6 minus 3, this 3 got included. So this like sum minus k is these, if we take 1 plus 2 plus 3, it's like 6. So what we need 3. So what we have to subtract? We have to subtract this 1 plus 2. So it's like 3. So this 3 gets included. Now you got it, right? So let's code it. If the solution is actually better. Let me first discuss our time complexity, guys. For the time complexity, what do you think the time complexity is? When we find something in the map, the time complexity is, you know it. It's log of n. So like m dot find takes big O of log of n, right? We are running a loop from 0 to n. So basically our time complexity for the loop is big O of n. It's gonna get multiplied. So our final time complexity, will be big O of n log n. Here I think it's much better than big O of n square that we had in the brute force approach. Sorry, for the space complexity, I think it got messed up and it is now big O of n because we are using map, right? So it's basically big O of n for worst big O of n. It's around big O of n. So guys, it will actually be big O of n plus 1 because we also included that 0 part when there is no element in our array. There is like some 0 is always present in every array, right? So it's okay. Since time complexity matters more, so it's better. Now let's try to run this, if it is actually correct or not. Better approach. Sort size and then then we'll have unordered map MP of 0 is equals to 1, because we always have a sum 0 present in an array. Now we have to calculate sum equals to 0 comma count, that will be our answer. Now we'll go for int I is equals to 0, I less than n, I plus plus. Now what we have to do is we have to calculate this sum and then check if mp dot find sum minus k start to, like, if we start to remove the minus k, so is such element present in the map. If we get sub arrays present with sum minus k sum, then that is our one of the solution. So count plus is equals to mp of sum minus k, and then again we'll update mp with the sum plus plus. If we already have that sum present in the map, then its count will get increased, and if not, then it will get included. And then we have to return count. Sorry, this is spelling mistake. Yeah, I think we are done with the solution. This is prefix sum, guys. Okay, we have finally solved. Oh my god, we improved a lot. Better than 72%, not bad. So whenever you solve a question, you always go and see the topic it belongs to. I think I generally do. So I think we solved the question the way they wanted us to. We did with the prefix sum. We included the hash map table to just calculate our, to include the missing, you can say the missing sub arrays. So we are done here. I think now you understood the question and the approach, that the approach was actually simple and easy to understand. We'll meet the next day on the